Alright, we're going to learn about the chain rule now. And this is one of the most useful rules for taking derivatives of functions you can ever learn. So here it is. It says that if y equals f of u, and that's a differentiable function of u, and u is g of x, and that's a differentiable function of x, then y equals f of g of x, which is a differentiable function of x, and dy dx is dy du times du dx. Or equivalently, the derivative of f of g of x dx is f prime g of x times g prime of x. What the heck is all that about? Well, it's pretty simple in plain English. It says that the derivative of a composite function, where you have a function inside a function, that's the derivative of the outside function times the derivative of the inside function. So whenever you have a composite function, you take the derivative of the outside function first and multiply it by the derivative of the inside function. And it'll be clearer when we work a few examples. So, for example, let's find the derivative of y equals x squared plus 3 to the fifth. So sometimes the hardest part is figuring out, well, what is the outside function and what is the inside function? So raising it to the fifth power is the outside, and all this stuff inside the parentheses is the inside. Okay? So y prime is going to equal the derivative of the outside part. So that's 5 times the inside function raised to the fourth. So we took care of the outside derivative. Now we multiply by the derivative of the inside, which is 2x. And our final answer would be 10x, x squared plus 3 to the fourth. Now isn't that a great rule? Because that's a lot easier than multiplying out x squared plus 3 5 times and then taking the derivative of each term. Okay, let's take a look at this. We have the square root of x squared plus 3x to the third. So let's use laws of exponents to rewrite that as x squared plus 3x to the 3/2 power. Remember, I can replace a square root with an exponent raised to the 1/2 power, okay? So the outside function is raising it to the 3/2, and the inside function is x squared plus 3x. So y prime is 3/2 times the inside function. Notice I do not touch the inside function while I'm taking the derivative of the outside part, okay? When I subtract 1 from 3/2, I get 1/2. That takes care of the derivative of the outside part. Now let's do the derivative of the inside. That's 2x plus 3. And you can just leave it like that. Okay, let's take a look at this one. Let's rewrite this as 2 times 6x cubed plus 3 to the negative 2 power. So I don't have a fraction anymore. Okay? So the outside function is the negative 2 power, and the inside function is 6x cubed plus 3. So that means that dy dx is going to be negative 4 times 6x cubed plus 3. And be careful, when we subtract 1 from our exponent, we get negative 3. And now we're going to multiply that by the derivative of the inside function, which will be 18x squared. And if you want, you can make that, let's see, 4 times 18 is 72. So that's negative 72x squared. Let's put that back in a fraction for our answer, okay? Over 6x cubed plus 3 cubed. Okay, so guess what? You can also do the product and quotient rules inside the chain rule. So our outside function here is the cubing function, and the inside function is that fraction there, 2x plus 5 over x squared minus 3. So dy dx is 3 times the inside function, this time raised to the second power. And now I have to do the derivative of the inside function, and it's a rational function, so we have to use the quotient rule. So it's going to be 2 times x squared minus 3 minus 2x plus 5 times 2x all over the denominator squared. So that's the calculus. The rest of this now is just cleaning things up. So I have 3 times 2x plus 5 squared over x squared plus 3 squared and it's going to be 2x squared minus 6 minus 4x squared minus 10x over x squared minus 3 squared. And notice that I have an x squared minus 3 squared and another one here, so I can write that as x squared plus 3 to the fourth. And then on top I've got a 2x squared minus 4x squared and a minus 10x and a minus 6. And if you wanted to, you could factor out a negative 2, but you don't have to. That's good enough. My last two examples are going to involve sine functions. So here my outside function is tangent and my inside function is 6x. So y prime is the derivative of the outside function. So the derivative of tangent is secant squared, and I'll leave the 6x alone, and then times the derivative of the inside function. Well, the derivative of 6x is 6. So this is 6 secant squared 6x. And here's the last one. Now, this one's kind of tricky because we have more than two levels here. We have the outermost function is the cubing, then the middle function is the sine, and the innermost function is x squared minus 3x. So it's just like peeling an onion. We're just going to work from the outside in. So here we go. Y prime is, okay, we're going to take care of the derivative of the cubing function. So that's going to be 2 sine squared of x squared minus 3x. Now we've taken care of the outermost. Now we're going to do the middle, which is the derivative of sine. So that's going to be cosine of x squared minus 3x. And finally, we're going to take the derivative of the innermost function, which is the x squared minus 3x. So that all gets multiplied by 2x minus 3. And we usually put our trig functions last. So if you want, you could write it like this. Whoop, that's a pretty ugly 3, isn't it? And cosine x squared minus 3x. And that is how you use the chain rule.